Equations for uniformly accelerated motion. When an object starts moving, it covers some displacement with respect to time. It may have some velocity and acceleration. When we talk about uniform or constant acceleration, then we can relate the velocity, time, displacement, and uniform acceleration of the object by the help of three equations. And for representing velocity, initial velocity of the moving object, we denote it with the help of vi at time t is equals to 0 seconds. So initial velocity of the object is represented by vi, and final velocity of the object at time t seconds is represented by vf. Acceleration of the particle or object is represented by a, and distance or displacement traveled in time t seconds is represented by s. First equation of motion is Vf is equals to Vi plus At. Second equation of motion is S is equals to Vit plus half At square. Third equation of motion is 2As is equals to Vf square minus Vi square. Motion of body under gravity, free fall motion. Acceleration produced in the body by the force of gravity is called acceleration due to gravity. It is denoted by the symbol small g. In the absence of air, all bodies fall freely with the same acceleration near the surface of the earth. It is called free fall motion of the body. Average value of g near the earth's surface is taken as 9.8 meter per second square in downward direction. The equations for uniformly accelerated motion can also be applied to free fall motion of the objects by replacing a with g, small g. Newton's laws of motion. Cause of motion is force. Here this person is applying force on this object. This person is pushing this object, and the force applied by this person on this object is cause of motion of this object, because this object is changing its position from one point to another point. So the force applied by a person is the cause of motion of the object. Newton's first law. An object remains in its state of rest or of uniform motion in a straight line unless some external force acts on it. So according to Newton's first law, if object is in a state of rest, it will remain in rest unless an external force applies on it. And if an object is in state of motion, it will continue its motion unless an external force acts on it. If no net external force acts on an object, then the body cannot accelerate. Newton's first law is also called the law of inertia. Net forces is equals to 0, then change in velocity is equals to 0, then acceleration is equals to 0. Newton's first law of motion. According to Newton's first law of motion, an object at rest will remain at rest. So here this object is at rest and it will remain at rest. But when we apply an external force, then this object starts moving unless acted on by an unbalanced force. An object in motion will continue with the constant speed and direction. Now this object is in the state of motion. It will continue its motion unless acted on by an unbalanced force. Now this net is trying to stop this ball, and because this net is applying force on this ball, so it will stop and its motion will be stopped by the help of this external force applied by net. From this example, we can understand that When object is at rest, it will remain at rest. When an object is in a state of motion, it will continue its motion unless this object is acted by an external force. So when an external force is applied on this object, it will change its condition of rest and it will start moving. And when this moving object will be acted by an external force, it will stop moving and it will be stopped by the help of an external force. Inertia is the property of an object that resists acceleration. Inherent property of all the objects by virtue of which they cannot change their state of rest or uniform motion along a straight line by their own is called inertia. So due to inertia, object at rest tries to remain at rest, and due to inertia, object that is in motion tries to continue its motion. Inertia of an object is measured by its mass. The greater the mass, the greater is the inertia, as greater net force is required to change the velocity of objects with greater mass. Here is an example of inertia to clear your concept. These two balls are in a state of rest and are placed on the cardboard. When we suddenly remove the cardboard, then these balls goes directly into the glasses. Because both the balls have their own inertia, so due to inertia of the balls, these balls tries to keep in the state of rest, and when we move the cardboard, these balls directly goes into the glass and they do not move with the cardboard. This is the property of the objects that is called as inertia. Newton's second law of motion statement: when the force is applied on a body, it produces the acceleration in its own direction. The magnitude of acceleration is directly proportional to applied force and inversely proportional to the mass. This can be represented by the help of equation A is equals to F divided by m. For an object having mass m, when we apply force F on the object gets acceleration in the direction of this force, and it is A is equals to F divided by m. Here we have A is equals to K into F divided by m. K is constant of proportionality, that is equals to 1, and we can get A is equals to F divided by m. For force, we can write F is equals to m into A, acceleration. SI unit of force is Newton and it is a vector quantity. When mass of the object is same, we can relate that for greater force, acceleration will be greater. For smaller force, acceleration will be smaller. But when we change the mass, we can see that for a balloon whose mass is less than the mass of ball, when we apply the same force on the balloon, its acceleration is larger because mass of balloon is less than mass of ball. So for the same force, acceleration is larger for balloon. But when we talk about this ball and we apply the same force that we applied on the balloon, so for the same force on this ball, the acceleration is less because mass of ball is greater than mass of balloon. So due to greater mass, acceleration is less for this ball. Newton's third law of motion, its statement is: to every action there is always an equal and opposite reaction. For example, here when this football is kicked, this foot is applying an action force on this football, and in return this football is applying reaction force on the foot. If FAB is equals to force exerted on football in this direction, FAB is force exerted on football by this foot, and FBA is force exerted on foot in this direction, in opposite direction, by this football. So then according to Newton's third law of motion, FAB is equals to minus FBA, action force is equals to minus reaction force, because both are opposite in direction. Action force is in this direction and reaction force is in this direction. So we use negative sign here. Example of Newton's third law of motion is a book lying on a table and swimming. Another example of Newton's third law of motion is shown here. When this cannon applies force on the metal ball in this direction, the action force, due to this a reaction force is applied on the cannon, and the cannon is slightly shifted due to the reaction force. This is also known as recoiling.